Electricity has become a vital part of today's society. The most basic level is the electrical current, which is simply a closed path which electricity may flow through. Circuits have three basic components, which are the current, voltage, and resistance. Currents are measured in amperes. An amp is the measurement of how quickly electrons move per unit of time. Voltage is the electrical potential of the electrons and measures how badly electrons want to move. Resistance is measured in ohms and is characterized by the degree to which it impedes electron movement. Georg Ohm first discovered Ohm's law in 1827, which he incorporated in his book The Galvanic Circuit Investigated Mathematically. Ohm conducted his experiment using a thermocouple and a galvanic meter. Ohm's law was not well received at first, and many believed his experiment was not carried out properly because his critics thought his ideas were unrealistic. This caused his experiment and its results to not become widely accepted until 1840. Ohm's law is the most basic and arguably the most important mathematical relationship between resistance, current, and voltage. Dang it.
So to better explain circuits, we can show you a simple circuit diagram, which I can start off by drawing the battery itself, which this long line will represent the positive end. The smaller line off to the right will represent the negative end. And then we can draw the conductor, just be straight lines and right angles. The resistor, and finish it off with the conductor on the other end. So the resistor we can measure in ohms. We'll just have one of these in our experiment. It can be just what we use in the experiment, or it can be a light bulb. And then we'll actually be measuring the current, which is I. And according to electrical engineers, it flows this way around the circuit. And there's also voltage, which is the potential energy. And as we can see from the equation, this potential energy is actually slowed down by the resistance, which actually gives us I in our equation. The lab we will use representing Ohm's law will be measuring amps, and it will be based off of a traditional circuit diagram. These being the conductors, which will be represented by wires, with the current running this way. The resistor, which will remain constant, represented by a resistor measured in ohms. We'll have varying voltage sources or batteries, which I will add on to the system. And we'll go up to 15 volts. Bruce will be recording the data off of this measurement device, which will be measured in amps.
10.5 volts. 10 amps. 12 volts, so that's 11.9. Testing 13.55 volts. And the last one, 15 volts. All right. So in our experiment, we used the 3 different variables: volts, amps, and ohms. We decided to keep our ohms constant, or our resistor constant. And the 2 variables that we measured, the 1 variable that we measured was amps in terms of volts. So our volts was going to be our independent variable, what we were going to change, and as a result, what we were going to be measuring was going to be the amps, the dependent variable. And so this is our data chart, this is our graph, and as you can see, it's a linear graph. So we know that the relationship between amps and volts is that amps are directly proportional to volts. This is our mathematical model. Y equals mx plus b. Y is going to be amps, everything on the y-axis. V is going to be, or x is going to be V, everything on the x-axis. And B is supposed to represent the amps whenever volts is equal to 0, but whenever volts are equal to 0, amps are equal to 0, therefore we have no V. Our equation was amps is equal to 0.99 amps over volts times V.
Alright, so our mathematical model, A equals 0.99 A over V times V, actually has 3 variables. Because look, if you see here, this is our current in terms of amps. And this obviously is just our volts, or what you'd be plugging in. But also we have this constant right here, and this constant is actually ohms. And ohms. So how do I know that 0.99 is our ohms? Well, if you think back to our experiment, we said that ohms would be our control. So we said that this number is going to be constant no matter what else we change. And also you remember on our whiteboard it said that 0.99 was ohms throughout every single trial that we did in the experiment. So another way we could think about this equation is our current equals the resistance, or the ohms, times the voltage, right? I just replaced 0.99 with R, or ohms. And this right here is the universal equation of Ohm's law. And using this, we can find our other 2 variables. We can find what V is going to be by dividing across R. So voltage is equal to the current divided by the resistance. And we can also just find R by dividing both sides by the voltage. So we find that the resistance is going to be equal to the current divided by the voltage. And this right here is really why Ohm's law is the most significant mathematical relationship between the resistance, the current, and the voltage.